let's talk about probability. This will be a full review on probability. Basically, we're going to talk about everything. We're going to talk about the basics, how you denote, probability, the formulas that you use, some of the common terms, types. Then at last, we're going to solve some practice questions. So we're going to do all these questions to just familiarize ourselves with how probability is. So basically, this will be our roadmap. Now, what are the basics? What are we supposed to know? So we often make statements about probability. For example, someone can say there is a 90% of rain today. So if there is a 90% of it raining today, that is just shows us there's a chance that it can rain or it might not. So basically, by saying that, we are referring to probability. Or let's say after your continuous assessments, which we call your CS, then you feel after writing, let's say, a math test, then you ask your teacher, is there a chance if I'll clear, if I'll pass or not? So basically, in everyday life, we are always talking about probability. Therefore, probability in simple terms will just be the likelihood of an event happening. Now, what are we supposed to know in terms of probability? The largest number that you can have in probability is 1. The smallest that you can have is a 0. Therefore, the range of probability, the range of values for a probability will be from 0 to 1. That's what we need to understand. Now, overall, what are some of the things? So the probability of an event is never also negative. So it can't be negative. That is another important thing that we're supposed to know. If it is never negative, then what is the range? So therefore the range, probability will just be, let's say, probability represented by P of an event happening. Let's say this is event number 1. It should just be between 0 and 1. Okay? So now, an event that cannot occur is the one that has 0 probability. And such an event is what we call an impossible event. It can't happen. Okay? Then an event that it can't occur is also called a null event. Then on the other hand, let's say there is a certainty that this event can occur, and probably maybe it's equals to 1. So because it is equals to 1 and is able to occur, this event is going to be called a certain event, meaning we're really certain that it's going to happen. Then we can also call it a sure event. We are really sure that it is going to happen. So basically, those are some of the basics that we're supposed to understand about probability. Now, what are the notations? How do you denote probability? Number 1, you can use a fraction. A fraction in this case, let's say an event overall, let's say you tossing a coin. For a coin, you can either have a head or a tail. Now, these two events can occur, but in terms of a fraction, since these are two events, we're going to say out of 2, we're only going to, let's say we're tossing is only once, and maybe we're just expecting a head. So for you to have a head, it's just 1/2. That is a fraction. Okay, basically you can denote it like that. Then you can also denote probability using a decimal. Now a decimal in this case, like our example, we had 1/2. 1/2 is the same as 0.5, right? If I divide 1 divided by 2, this is also an expression or how you can denote probability. Then The last common one is, or you can also denote it in terms of percentage. So in terms of percentage, let's say the same 1 over 2 that we have, but now I want to express it in terms of a percentage. So what are we going to do? Percentage is out of 100, so we're going to multiply by 100. Now if I divide 2 into 2, that is 1. 2 into 100, that is a 50. A 1 multiplied by 50, that gives me a 50. But now because I multiplied by 100, so this will be 50%. So half or 0.5 or 50, it's the same thing, but you're just referring to them in terms of how you want to express them, whether you want to express it in terms of a percentage or not. So basically this is how we represent probability. Now what is the formula for probability? Now probability is going to be given by, it is going to be equals to the favorable outcomes Now we're going to talk about all these terms as we start talking about, the common terms that you're supposed to use, divided by the total possible outcomes. So basically what this talks about is the favorable outcome is the one that you are expecting, to have. Then the total possible outcomes, these are all the outcomes that can be there for that event. So that is very important. Now let's talk about the common terms. Terms like bias. If we say this is bias, what do we mean? As if we say an outcome, if we say a trial, let's say you also say a random selection. These are some of the common terms that we have under this topic. Now when we're talking about bias, in this case, if we say these results are biased, meaning you were not being fair, in terms of how probably you are picking the sample, therefore we can't generalize that your results are really fair. For example, in a population where you're supposed to randomly pick people, let's say you just randomly select only men, therefore it will show that you have neglected the other people, of which they are also part of the population. Or let's say in other instance, maybe you just selected brown people, only people who look brown. Basically they are not being fair. Or maybe people who look like you, maybe like that. So basically you're not fair, so that means that your results might be biased. Then we're talking about an outcome. This is the result of what you're performing. If it's an experiment, let's say you're conducting let's say a research, the outcome, the result of the performance is that we're calling an outcome. Then a trial is the actual performance now. The same performance that you're doing, let's say you're tossing, so that you get a result. Or let's say you're doing an experiment so that again you get a result. That would be your trials. Basically that. Then random selection, on the other hand, instead of just being biased, now it's like in other terms, like the opposite. Now you're not being biased, you are selecting without knowing or considering who is who or what is what. You are just speaking randomly. So basically these are some of the terms that we are supposed to understand on this topic. Now there are what we call logical connectors. These will be helping us to solve questions. Let's say I've got a logical connector like both. It means maybe they want you to pick, let's say an event is going to yield, let's say, what is the probability that you are going to have both maybe male and female. So because it's both, or it also goes with and. So basically this one, every time they give you that, it means you're supposed to multiply those two events or those two outcomes. So that is the first logical operator, then or logical connector. Then What if they ask you either or? Okay, either or. So every time you have either or, it means you are adding. Okay, in this case there is addition. Okay, then another term that you're supposed to know in terms of logical connectors: neither nor. Okay, meaning you don't want any event there, you don't want any result. So because you don't want, you're subtracting. Okay, subtracting or subtraction, basically that. Then in some instances they're also going to ask you, let's say at least maybe you're going to have a tail. So every time you have an at least, this just equates to, it means it's an inequality. An inequality in this case, this is greater than or equal to. So a good example that I can give here, let's say they've asked you to let's say at least 3. At least 3 would mean you want greater than or equal to 3. Okay, means greater than or equal to 3. Basically these are some of the connectors. Now what are the types of probability? Basically, you know, there are several types of probability depending on what they've given you. So there's what we call theoretical, there's what we call experimental. We're going to talk about these one by one. There's also what we call conditional. Then sometimes the results can be combined. Okay, let's say combined events. So basically these are some of the things that we're going to talk about. Now when we talk about theoretical, what do we mean as a probability? This one is going to be based on what you know already. Okay, it's going to be based on known outcomes. So for example, you know that a coin has a head and a tail. Basically that you already know the outcomes, but you're just trying to now find out. Okay, let's say also a dice. You know that a dice has like six sides. Okay, let's say this is our simple dice there. Okay, if it has 6 sides, you already know. So basically you know the outcomes, but now you're just now trying to find which outcome are you going to have every time you do a trial. Okay, then this one mostly you're going to use mostly uses formulas to find the answers. Sometimes it also uses logic. Okay, so you're going to realize as we start to solve questions. So basically that. Then on the other hand, we also have what we call an experimental probability. Now this one is going to be based on actual trials. Okay, the actual trials themselves. So because it's an experiment that you're doing, or the experiment itself, so you can only get this type of probability when you are doing experiments. Example, the same example, you're tossing a dice, or you're rolling a dice, or you're tossing a coin. Okay, basically that. Now there's also what we call conditional probability. Now this one, even just the name conditional, there are conditions attached. Okay, it would depend on conditions like replacement, especially replacement. Now this one is most common, mostly in exams. Okay, they give you a condition. Okay, so the key examples that we can talk about here is independent events, so when you have independent events, when you also have dependent events, when you also have what we call mutually exclusive. Okay, mutually exclusive events. So basically we're not talking about independent events. So these independent events, the way they are, we're talking about replacement. Okay, then independent, there is no replacement. So what we mean here replacement is, let's say from a box you've gotten, let's say a ball, that marble, or let me say a marble, then that marble you replace it again. After getting it, you replace it because it's not the outcome that you want. Let's say from this box you want to get a yellow ball, but now from during a random picking you're picking, then you've let's say you've picked a black ball. Since you want a different color, you're going to take that black ball back again into the box. So basically you are replacing it. Then dependent on the other hand is, let's say you're looking for a white ball, then upon random picking, let's say you get a black ball again. Now you're not replacing that black ball again into the let's say the sampling material or where the balls are. You're just going to place it on the other side, and you are going to continue doing that. You're going to continue doing that until you get the outcome that you want. Then mutually exclusive, on the other hand, even just the name says, so these ones, they cannot happen together. Okay, events that can just never happen together. Okay, because maybe they're in different categories or like that. So that is also very important for us to understand. Then sometimes events can be combined. In as much as other events are mutually exclusive, they can only exist alone. However, events can also be combined. Okay, now the methods that we are going to that we mostly use in terms of combined events, methods like you are going to list outcomes. So you can, there's what we call listing. You can also talk about Venn diagrams. Okay, so these are high yield because they usually combine a lot of events, mostly also in the exams. Okay, so grid squares. You can also use tree diagrams. Okay, tree diagrams. Now basically when you are listing, you're just listing the events. Okay, let's say there's event 4 and event 5, and if you say 5 and 4, these are two different events. They don't mean the same. Okay, in as much as you have so the way you are listing is very important. What comes first, what comes second, what comes third is very important. However, you've just combined these events. Then on the other hand, you can also use Venn diagrams. For example, let's say you've been given odd and prime numbers in a universal set. So basically you've combined odd numbers and prime numbers. Then grid squares, on the other hand, this one, you have a sum of two. Let's say you have a sum of two dice outcomes. Okay, so let me say a grid square. Let's say from this is just a simple one. Let's say I've got this and I've got that. Okay, so all these boxes are just supposed to be like well, nicely written like that. Now if we're going to do a grid square, let's say the first event is this side. Okay, let's say the first is this side, the second event is on the other side. Okay, whether it's these are 2 dices or 2 coins. But let's say just pick what is in my head. Let's say this first event, the outcomes that we can have, let's say it has 1, 2. Okay, then let's say for a dice, let's say this is a coin, then on the other side, let's say I've got a dice. Okay, these we've combined them. Now for a dice, how many outcomes are you going to have? Okay, you can have 1, 2, 3, 4, 5 and 6. Basically those are the outcomes. Okay, let me just do this to just explain what I'm talking about. So basically, what are we going to be doing? We're going to be getting an event from here and an event from there. We put in this first box that we have here. So if I put that, I'm going to have 1, 1. Then in the next box, I'm going to pick 2 and 1. However, you're always starting with the first event. So 1, 2. Then even in the other one, 1, 3, 1, 4, 1, 5, 1, 6. And you come down here again, you're going to come 2, 1 like that. Okay, let's say this is 2, 1. Then 2, 2, 2, 3, 2, 4. Okay, let's say here. Okay, these are just the events. Then we can ask you a lot of questions from here. Let's say from your results, what is the probability that you're going to have, let's say, even numbers? Okay, even numbers. So which ones are even numbers? You got this one and this one. Okay, basically you get those 2 outcomes and you divide it by the total of what you have in all the boxes. So in this case, let's say I haven't included this one and I haven't included the last one, just the ones I've put in red. Let's say I've got 1, 2, 3, 4, 5, 6, 7, 8. Since I've got 8, this is just an example. Since I've got 8, however, if we want only the probability of us getting 2 even numbers, which are those ones, so the outcomes is 2 over the total, which is just, let's say we said is 8. So that will be our probability. However, it can be simplified further to be 1 over 4. That's what we're just talking about here when we're talking about grid squares. Now on the other hand, you can have a tree diagram. You can also use a tree diagram to show, you're going to be using things like these ones. So I'm going to solve all the questions to just familiarize yourselves with what we are talking about. Okay, so basically this is a good introduction on probability. Now to just make us understand, let's now solve some questions, practice questions. Now as we start solving some practice questions, I would want us first to know the types of numbers. Okay, there are a lot of numbers. You can watch our videos on the types of numbers, sets of numbers, whole numbers, natural numbers. However, in this topic, on this topic, the most common ones that I've seen, that you are supposed to know, you have to know prime numbers. You have to know odd numbers. You have to know even numbers. Okay, you have to also know perfect squares and other forms of numbers. What I'm just talking about is not all the types of numbers, but mostly they are going to ask you about this type of numbers if you really know what they are. Now when we're talking about prime numbers, numbers that are divisible only by 1 and itself, it means only 1 can go into that number and itself are the only 2 numbers that can go into that number. Those are called prime numbers. Numbers like 2. How many numbers can go into 2? So you can have 1 go into 2. You can also have 2 again divide by itself. So basically those are prime numbers. So from 2, what other number are you going to have? You're going to have 3. What other number? You're going to have 5. You're going to have 7, and you're going to be going like that. You can't say 8. 8 has a lot of numbers that can go into it. Okay, 1 can go, 8 can go, 4 can go, 2 can go, basically that. So you can't write 8, so meaning you're going to go like that. Now odd numbers on the other hand, these are numbers that are not divisible by 2. They are not divisible by 2. For example, 1, okay, it always gives me a remainder of 1. So if I divide 3 by 2, it always gives me a remainder of 1. Okay, 5, it will give me a remainder of 1. 7, a remainder of 1. Even numbers, now even numbers will be the opposite in terms of odd numbers. These ones can be divided by 2. Okay, they are divisible by 2. So numbers like 0, 2, 6, 8. You can also put negative numbers. 2 can go into negative 4, into negative 8. Now 0 is a negative number, it's an even number, because if I say 0 divided by 2, what do I have? I have a 0. Okay, so basically that. Now a perfect square on the other side, it's called perfect because if I go, it's a square, by the way. If I get 1, so all the numbers that we have, 1, 2, 3, 4, 5, 6. Now if I square all these numbers, the result that I'm going to be getting are what we are calling perfect squares. So if I square 1, if I square 2, square 3, I square 4, I square 5, and I square 6, and I'll be going like that. What answers am I going to be having? So 1 squared, it is just a 1. 2 squared, that is just a 4. 3 squared, that is like a 9. 4 squared, that is like a 16. 5 squared, that is like 25. 6 squared, that is like a 36. So basically these are what we are calling perfect squares. Okay, so this is about the types of numbers that you're supposed to know. Now let's solve some practice questions. Okay, so the way you can be doing this, like we earlier said, you can be pausing the video, you try out to just familiarize yourselves with how we solve probability questions. So with me here, I have question 1. What is the probability of rolling a die or a dice? Okay, now you are rolling a dice, so what is the probability of that? So let's say, what is the probability of rolling a die? Let's say because there's no question here, what is the probability? Let's say, what is the probability of rolling a die, of rolling an even number on a fair die? Okay, so let's say us getting an even number after we roll this die. Okay, this question was not complete. Let's say us getting an even number after we roll this die. What are we going to have? Okay, now what numbers do you have on the dice? We got 1, 2, 3, 4, 5, and 6. Since there are 6, these are what we call total outcomes. Okay, then from these 6 outcomes, which ones are even numbers? Okay, even numbers, we've said those numbers that can be divided by 2. So 2 can be divided by 2, 4, and 6. Okay, so those 3 are what are going to be our outcomes. How many outcomes do we have? We've got 3 outcomes, or what we call favorable outcomes. That's what we want. So therefore, what will be the probability of this? So the probability of getting an even number will be equals to the favorable outcomes, which are 3, divided by the total outcomes, which are 6. So therefore that will be our answer, but we can simplify it further. 3 into 3, that is a 1. 3 into 6, that is a 2. So we have a 50-50 chance, or let's say half, of getting an even number. So that is how we solve this question. Let's solve the second one. What is the probability of picking a prime number from 1 to 20? what is the probability of picking a prime number from 1 to 20? Okay, now I'm not going to list all the numbers from 1 to 20, but however we can get the prime numbers. Okay, so what would be the prime numbers in this case? Okay, numbers that can only be divided by 1 and themselves are what we are calling prime numbers. So 2 can be divided by 1 in itself, 3, 5, 7, 11, 13, 17, 19, from 1 to 20. That's what they've given us. Okay, now we can't put numbers like 9 has got other numbers that can go into it, like 3. Okay, so basically these are the numbers, these are the prime numbers that we have. So these are what we are calling outcomes. That is what we are looking for. So how many are these ones? We got 1, 2, 3, 4, 5, 6, 7 and 8. So in this scenario we have 8 outcomes, or favorable outcomes. So we have 8 outcomes. Now what are the total outcomes for this one? We've been given it's from 1 to 20. Okay, so basically what would be the probability? So the probability of getting a prime number from 1 to 20 will be equals to the number of outcomes, or favorable outcomes, which is 8, divided by the total outcomes that we have, which is 20. Now you can divide this into, you know, smaller pieces. So if I look for a number that can go into 8 and 20, which number? Let's say 4. 4 into 8, that is a 2. 4 into 20, that is a 5. So basically that would be 2 over 5. Okay, so that will be our probability. Let's solve another one. We are told, after tossing a coin, what is the probability of getting a head? Okay, after you've tossed a coin, what is the probability of getting a head? Okay, what are the outcomes every time you you toss a coin? Okay, you can either have a head or a tail. So basically there are 2 outcomes that you expect. Okay, however, what outcome do we want? Okay, the favorable outcome in this case, we only want the head. Okay, we only want the head, meaning we only want one outcome for ourselves. Okay, therefore what will be the probability? The probability therefore will be equals to the probability that you're going to have a head will be equals to, what do we want? We only want one head. Okay, so that is 1 over how many outcomes do we have? The total outcomes, you can either have a head or a tail, which are 2. So basically it's going to be half. It's going to be a 50-50 kind of a scenario. What if we introduce Venn diagrams? How do we solve probability when you're given Venn diagrams? Now if the universal set is from 1 to 12, then we are told X are odd numbers, then Y are prime numbers. Then we are told to show this information on the Venn diagram, number 1. Number 2, we are told to find the probability of these. Probability of X complement, Y complement, X intersection Y, X union Y, X union Y complement. Okay, they're asking us to find the probability. So basically that. Okay, so how do we first show this information on the Venn diagram? So let me just draw my Venn diagram. Let's say this is our Venn diagram. Allow me to draw it here. Okay, there is a Venn diagram, and we put, let's say this is our, okay, let me just make it a bit bigger. Okay, hope everything is going to fit. Let's say our X is this one, our Y is that one. Now we have to list what these ones are. What is X from that list and what is Y from that list. Okay, so Y, X, if you are saying want odd numbers. Okay, odd numbers from that list. Numbers, when you divide by 2, they're going to give you a remainder. So basically we have, from this list we have 1, 3, 5, 7, 9 and an 11. These numbers, when you divide by 2, they're going to leave a remainder of 1. Then prime numbers, those numbers that have only 2 factors, 1 and itself. So okay, which ones are they? We've got 2, we've got 3, 5, 7, 11. Okay, basically these are the numbers that we have. Okay, so that is those are our sets. Now how do we show now these ones on the number line? Let's first pick the intersection from these sets. What is found in both of these sets? Okay, we have a 3 in both sets, we have a 5, we have a 7, and we have an 11. Okay, those are the numbers that are common in both sets, so we're going to put them in the intersection. So let's say we said we have a 3, we have an 11, we have a 5, and we have a 7. Okay, basically that. Now what remains in 1 after we remove the intersection? What remained in X? So we have 1 and an 11. These ones remain, so I'm going to put them where X is. So I'm going to put 1 here and I'm going to put 9 there. Then what remains in Y after removed everything? In Y we've removed all these ones, okay, and those are part of the intersection, so 2 is going to remain, so I'm going to put 2 here. Then what now remains after we remove all these numbers here? Now from this, what numbers are not in here in these sets? So basically we don't have a 4 here, so I'm going to put the 4 outside. 6, we don't have a 6 here, we don't have a 6 here, so I'm going to also put the 6 outside. What other number don't we have? We don't have a 12 in this set, or in these two sets, so I'm going to put a 12 also here. Then what other number don't we have? Do we have an 8 here? 8, no, we don't have an 8 there, so I'm going to put an 8 outside. Then is there any number that we've left out? Let's say I've seen a 10 here. Now is there a 10 in this set? No, there's no 10 in these two sets, so I'm going to put the 10 also outside. So basically this is our Venn diagram. Now you have to be very careful on this Venn diagram, because what you do with this Venn diagram, if any number is missing or if anything is wrong, then all your answers will be very wrong. They'll be wrong. Okay, so basically this, now that we've drawn our Venn diagram, we've answered the first question. Now the first question, we're asked to find the X complement, the probability of X complement. Okay, so what will be the probability of X complement? Let me write it here. Probability of X complement. X complement means what is not found in X. Okay, what is not found in X? So X, from our diagram, I'm able to see that it is this. Now what is not found in here, where X is what we're calling X complement. So what numbers do we have? We've got 1, 2, the 10, this one, and this one, and this one. How many are they? 1, 2, 3, 4, 5, 6. Those are not found in X. So since they are not found in X and they are 6, so that would be 6 over how many outcomes we have over a row. We're told we have from 1 to 20 to 12, so it is 6 over 12. Therefore, if we simplify this, 6 can go into 6, which is 1, over 12 into 6 into 12, that is a 2. So basically we have half as our answer. We come to B. B is the probability of finding y complement. Y complement what is not found in y. So y, in this case, it is this one. Okay, so how many things are not found in that? So we've got 1, 2, 3, 4, 5, 6, and 7. So basically that is our y complement. So that would be, the probability will be 7 over 12. Okay, since we can't simplify it any further, it will just end there. Then we come to C. C, we're trying to find the P intersection. We're trying to find the probability of X intersection Y. So the probability of X intersection Y, what is it going to be? How many numbers do we have in the intersection of X and Y? We've got 1, 2, 3, 4. So we've got 4. Therefore the probability will be 4 over 12. Okay, 4 can go into 4, 1, 4 into 12, that will give us a 3. Okay, that's how we solve this one. What about D? D, we're finding the probability of X union Y. X union Y, what is found in X and what is found in Y combined. So allow me to rub this part. We've already found these ones. Okay, so we're finding the probability of X union Y. So how many things do we have in the union of X and Y? So basically we just have to count how many are there. We've got 1, 2, 3, 4, 5, 6, 7. We only have 7 things between X and Y, and when you combine them, so we have 7 over 12. So it is going to end there. Then the last one on this question, we were trying to find the probability of X union Y, then the complement is outside. So the complement of X union Y, what is not found in X union Y, what is not found in these sets like that. Okay, so we have 1, 2, 3, 4, and 5. So basically there are 5 things that are not found in there. So it is going to be 5 over the total outcomes, which are 12. So basically that would be our final answer. So basically this is how we solve this question. Let's solve another question. So number 5, we're told, what is the probability of picking a 2-digit number from 1 to 20? Okay, a 2-digit number from 1 to 20. Now from 1 is a low, 9, 1 to 9, these are 1-digit numbers. Okay, so 1 to 9, these are 1-digit numbers, so you can't pick any number from there. So it means one numbers from 10 to from 1 to 20. Okay, from 10 to 20. So basically those are the numbers that we want. Okay, those will be from 1 to 20. Those are the 2-digit numbers. Now how many are they? So if I'm going to write them, so someone will just never subtract 10, and if you subtract 10 and 20 minus 10, that will just give you a 10, which would be wrong, because we have 10 itself, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Let's count them. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So basically there are 11. Okay, so never just make that mistake of write them if you have to, okay, to get those marks. So basically there are 11 outcomes. Okay, favorable outcomes, because 1 from 10 to 20. So basically, in this case, what will be the probability? The probability of getting a 2-digit from 1 to 20 will be equals to how many favorable outcomes? We've got 11 over what are the total outcomes? We have 20. So basically, this would be our answer, because this can't be simplified any further. Let's solve another question. What is the probability of picking a perfect square from 1 to 20? Okay, and what did you say perfect squares are? You get a number, you square it, and the answer that you're going to have is what we're calling a perfect square. So what's perfect squares? Now from 1 to 20, you know, if I square 1, I'm going to have 1. If I square 2, I'm going to have 4. If I square 3, I'm going to have 9. If I square 4, I'm going to have 16. If I square 5, I'm going to have 25. Now we don't want 25, and we just want numbers from 1 to 20. So basically 25 it will not be there, or 5 will not be there. So these are the numbers that we have. How many outcomes are these ones? You're able to see from here that there are 4 outcomes. So we have 4 favorable outcomes. Now how are we now going to find the probability? So therefore, the probability that we are going to get a perfect square will be equals to the favorable outcomes. We've got 4 over the total outcomes. We've got 20. That will be equals to 4 can go into 4, which is 1. 4 can go into 20, which is 5. So 1/5 or 1 over 5, that will be the probability, that will be the chance, okay, of getting a perfect square in that range from 1 to 25. Then we come to question number 7. Question number 7, we are told a coin and a die are tossed. What is the probability of getting a head and a 5? Okay, so we've got 2 events that are happening. Quite interesting. So how many outcomes can we have from a coin? How many outcomes can we have from a die or a dice? Okay, so basically this. So a coin, you can only have 2 outcomes. You can have a head or a tail. Basically, there are 2 outcomes for 2 favorable outcomes for a coin. However, for a dice, how many outcomes can you have? There are several outcomes from 1 to 6, because like we said, a die itself, a dice, okay, if we're going to just illustrate how a dice looks like, let's say this and that. Okay, let's say this is our dice. This dice, let's say it has sides 1, this side 2, 3 on the other side, 4 on the other side, let's say 5 down, and 6, the one that is facing us. So it has 6 sides, okay? And these sides are going to have dots. If where there is 1, you're only going to have like a dot like that, 1 dot. Where there are 2, where you have 2 on top, you're going to have 2 dots, okay? And where there are like 3, the other side, you're going to have 1, 2, 3. That's what a dice like looks like, okay, for what we're talking about. So basically, you have like 6. If you roll, if this one is rolled, you are going to, it can either fall on all the, or it can fall on either side. It can be on a 1, on a 2, on a 3, until to a 6. So those are the outcomes that we have. Therefore, we have 6 outcomes for a dice. 6. Now, if we have 6 outcomes, how many total outcomes now do we have? Okay, so that can only be, if you want you can do a grid square, but still, let's say like we did in a grid square, a coin has 2, 1 and 2. Okay, on the other side a die is going to have numbers like 1, 2, 3, 4, 5, 6. So basically, if you want, you can just multiply 2 and 6 and you get all the outcomes that you want. 2 times 6, that is 12. But just for illustration's sake, let me rub the 1 and the 2 here, and I put the head and the tail. Let's say this is the head and this is the tail. Okay, so you can have h1, you can have h2, you can have h3, you can have h4 or h comma 4, a head and the 4. You can have h5, a head and the 5. You can have h6, a head and the 6. Okay, that is what we have. Then you can also have a tail and a 1. You can have a tail and a 2. You can have a tail, a 3. So basically those are the possible outcomes that we can have. And if we were to count these ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's why I was saying basically you're going to have like 12 possible outcomes. Since you're having 12 possible outcomes, so what does this now mean? You can just multiply the outcomes. Most of the times when you're given 2 events happening at the same time. So in this case we're saying we have 12 possible outcomes. So now what do we now really want from these ones? Okay, so the favorable outcome that we want a head, which is number 5. We want a head and a 5. Okay, and we saw a head and a 5. It was one of the box. Okay, we had like h1, but there was a point where we had the h comma 5 and it was only 1. Okay, the other one that came close was a tail and the 5, but we don't want a tail and the 5. We want a head and the 5, since it is only 1 in that whole grid. Okay, meaning the favorable outcome that we want is only 1. Okay, so in this case, how many favorable outcomes do we want? We only want a head and a 5, so that is 1. Therefore, what would be now the probability? So the probability therefore is going to be the probability of us getting a head and the 5 will be equals to the total favorable outcomes, which is 1, over total outcomes, which are 12. Therefore it can be simplified any further. It's already simplified, so that would be our answer for question number 7. Let's solve another question. We are told that a bag has 2 green and 6 yellow discs. One disc is picked and replaced. Find the probability of picking yellow. Okay, now this is very important. Let me just highlight this. So this bag has 2 green, 6 yellow discs. Okay, one disc is picked and replaced. So you've picked it and you are replacing it, like that scenario that we talked about. Probably maybe you're looking for a certain color. If you don't get that color, you replace until you get that color. So now find the probability of picking a yellow. Okay, so the colors have been highlighted nicely. 2 are green, 6 are yellow. Now you want to find the probability of you getting a yellow. So what are we going to now have? So basically, what are the total outcomes? What is the total outcome? So we only have 2 green and 6 yellow. So 2 plus 6. That's what we have. So when you add these ones, we're going to have 8 outcomes. That will be the total outcome. However, what is a favorable outcome? What do we really want? We want yellow. Okay, now the yellow ones, how many are they? There are 6. So the probability that you're going to pick one yellow from these 6, the favorable outcomes, there are 6. Okay, therefore the probability that you're going to get a yellow from these 8 will be equals to 6 over the total, which is 8. That will be equals to, then you can now simplify. You're going to look for 2 numbers, or you're going to look for one number that can go into 6 and 8. Let's say 2 into 6, that 2 into 6 that gives us a 3. 2 into 8, that gives us a 4. Okay, so you're going to have 3 over 4. That is the probability. Now, like we earlier said, you can either express it as a fraction, like we have shown. You can express the same answer as a percentage. You can also express it as a decimal. So if I want it to be, let's say, what is a percentage? If they ask you find the probability percentage of picking a yellow, you would have multiplied by 100. 4 into 4, it's 1. 4 into 100. 4 into 10, that is a 2, remainder 2. 4 into 20, that is a 5. So it means you are going to multiply 3 and a 25. 25 plus 25, that is 50. 25 plus 25, that is a 50. 50 plus 25, that is like 75. So you're going to have 75. So this just shows you that after you've done that, and you are trying to, there's a 75% chance of you picking a yellow, and that makes sense, right? Because we only have 2 green and 6 are yellow. There is a high chance that you're going to pick a yellow disc than it is for for those 2 discs which are green. So it means only 25% remains. 25% remains for the green ones. So that's what this means if you're going to express it as a percentage. If you're going to express it as a decimal, just divide like that. 4 into 3, that is a 0. That is a 0. Then 4 into 30, you put a point. 4 into 30 is that what? 4, that is like 6. Is it 6? 6 multiplied by, yeah, but if it 28, let's say 20, 7, no, 8, 4 multiplied, no, that is like a 32. Okay, like that. And you're going to be going because if I say 4, 4, 4, 4, 4, this is 1, 2, this is like 20, and I put another 4, that is like 6. From here 6, 16, 20, 24. If I put another 4, 28. How many are they? 1, 2. Okay, that's 7. So it's going to go there 7 times, remainder 2. Into 20, it's going to enter 5. Okay, 0.75. So 0.75 is the same as 75%. It is the same as 3 over 4. So basically that. Okay, so that's how you're going to express it in all those denotations, how you denote them, how you denote probability. Okay, then we have another one. Question number 9. 2 dice are rolled. What is the probability that the sum is 10? Okay, 2 dice are rolled. What is the probability that the sum is 10? Okay, so what combinations on the dice can give you 10? Let's write them. We know that a dice you can have 1, 2, 3, 4, 5 and 6. What combinations here? Two combinations each can give you a 10. Okay, so if I get a 4 and a 6, are they going to give me a 10? Of course. So I'm going to say 4 and 6. These ones are going to give me a 10 when I add them. Sum means we're adding them. Then which other combination can give me a 10? 5 and 5 again. Okay, meaning 5 from one dice and 5 from another dice can give me a 10. So 5 and 5, it is another possible one. Okay, then which other one? 6 and 4 can also give me another one. So 6 and 4. So basically these are the common ones. Now, like I earlier said, when you are listing, 4 and 6 is not the same as 6 and 4. These are two different events. So basically that's why we've picked them like that, because what this means is that for the first dice it gave you 4, the second dice it gave you 2. For this one, the first dice gave you 6, the second dice gave you a 4. These are two different events. So basically that's why we're picking all of them. So basically these are the outcomes that we have, or the outcomes that we expect or that we want. So these are 3 outcomes. So therefore, what will be now the total outcomes that we're going to have? So like we said, if we're going to show a tree diagram which we're not going to complete fully, 1, 2, 3, 4, 5, 6, let's say this, then you have another line on top. You're going to have like let's say you have 1, 2, 3, 4, 5 and a 6, like that. So and you're going to draw all those lines and there'll be like a lot of them. So like we said, every time you have 2 events, how many outcomes do we have here? We have 6. On the other hand, we also have 6. Then what did you say? You multiply the 2. You're going to have 6 times 6, which will give you 36. Like we did for a coin and a dice, here we only had a head and a tail. There were only 2 and we had to multiply 6 on the other side, which gave us a 12. So for this case, since there are 2 dice, we are going to multiply 6 multiplied by 6. 6 multiplied by 6, that gives us a 36. Therefore, what will be the probability? The probability that you're going to have a sum which is equals to 10, that would be equals to how many favorable outcomes are we expecting? 3. Then what is the total possible outcomes? We've got 36. So basically that. Then you're going to look for 2 numbers. 3 into 3, that is a 1. 3 into 36. 3 into 3 is 1. 3 into 6, that is a 2. So you're also going to have half. Let me say you're going to have 1 over 12. Okay, that's like half, right? Especially in this scenario. So basically that. Then let's solve another question. So we are told that a bag has 3 red, and this has been highlighted in red, and 5 blue balls also highlighted in blue. 2 balls are picked without replacement. Find the probability both are red, or that both are red. So we've been told without replacement. Okay, without replacement. So here, if you want, you can use a tree diagram. But before we start solving using tree diagrams, let's just solve this one not normal without complicating things first. So we're trying to find the probability that these balls that we're going to pick, both of them are red. Okay, so what is the probability for you to pick a first red? Okay, so let's say this is a bag. Okay, and this is your hand. It has gone there, it has picked a ball, and there are a lot of balls in there. You've picked one red. Out of how many? Out of all the balls that you have. All the balls that you have, you've got 3 which are red plus 5 which are blue. Okay, so what is the final answer? So meaning the balls that you have in this let's say bag, they are 8. Okay, now from those 8 you've picked out 1. Okay, 1 which is red. Now what is the probability of you having a red? Okay, in the first instance, since there are 3 red, so the probability for picking a red for the first time, it is from those 3 divided by 8, which is the total. This is the first outcome. Okay, you've picked, let's say in that first instance you've managed to pick a red ball. Okay, you've managed to pick a red ball. So if you've managed to pick a red ball, you put that red ball aside. Okay, now you want to now pick for the second time. Now since you want to pick for the next time, because this red that you've picked, you really want it. Okay, so those are the ones that you want. So you put it aside, you've not replaced it. That's why you're saying without replacement. You're not replacing it back, it's what you want. Okay, so since you've not replaced it, how many red balls have now remained in this bag after you've picked 1? There were 3 red balls initially. Now you've picked out 1. You've managed to pick out 1, so it means you've remained with 2 red balls in the bag. Okay, over, since 1 was removed from all the total which is 8, you've now remained with the total of 7. So this is the probability of you 6 picking the second, because now that, let's say now you want to pick for the second one, you only have 2 red balls and 1 has already been removed, so you have 7. Overall you have 7. So the probability of you picking for the second time a red ball will be 2 over 7. Now the question is asking us to find the probability that both are red. What did we say when we say both? Okay, what did we say when you say both? So both is, those are connectors, and please don't forget your connectors, very important. So how they ask you will determine what you're going to use. Like we said, if we say both goes with and. Okay, both, we said you're multiplying. Then if we said either, if they said either, what is the probability of picking either a red or, let's say, a red or a blue ball? Either you are adding, so it means you're going to add those events. Okay, that is a plus. Okay, you are adding those ones. And then if they were taught to ask if we're neither, we don't want anything like red. If we pick, we neither want red. Okay, no, let's say blue or whatever. What are we going to have? It means we are subtracting those 2 events that we're going to get. Okay, minus. Then if they told us at least, it means it's greater than or equal to what we've been given. So basically those are the 4. You have to know those ones if you're going to understand and get all those questions. Well, the questions are going to ask you in your exam or in any assignment. So we have red and red. We've got these 2 reds, and we're finding we've been taught both. Both means multiplying, so it means you are literally multiplying these 2 events. So we're going to have 2 over 7. Now let me write them in order. The first event was 3 over 8 multiplied by the second event is 2 over 7. Then you just have to solve these ones to get your answer. Now if I multiply these ones, what do I have? 2 multiplied by 3 multiplied by 2 on top, I have a 6. Then 8 multiplied by 7 down, what do I have? I have a 56. Okay, is there any number that can go into both of them? Okay, let's start with the smallest one. 2 into 6. 2 into 6, that gives us a 3. 2 into 5, that is a 2, remainder 1. 2 into 16, that is an 8. So basically that would be our final answer, since it can't be simplified any further. Okay, so you're able to see that this diagram, or this was leading us to, because you are picking, you've picked the first instance, then you've picked for the second time, then again you are if you are again on, you're picking and you're picking. It's like it's leading you into a tree. Okay, now it's like leading you into what we call a tree diagram. Okay, so this same question, before we start solving more questions on the tree diagram, this same question, let's say you pick for the first time. Now how are you going to draw using a tree? Because a tree has branches, right? So you pick for the first time, that is the branch that you have. Let's say you pick for the first time, this is the first branch that you have. Then, okay, those are the 2 branches that you're going to have for the first time. For the second time, again, you're going to have other branches again. This one, and this one, again this one, and this one. Okay, now let's say this is the first instance, this is the second time we are picking. Okay, now what do we have? We have red and blue. So let's say this is red, this is blue. How are you going to show this in terms of a tree diagram? So basically, for red, what is the chance that you're going to pick the red for the first row? For the first row, we said it is 3 over, how many balls do we have over row? We have 8. Okay, now for the blue balls, what is the chance that you're going to pick a blue ball? That is 5 over 8. Okay, now if we try for the first time to pick, what are we going to have from this combination? This is what we have. But now if we want to pick now, let's say I want to pick a red. We've picked a red. Okay, if we've picked a red, how many reds were there? There are 3. Then we've picked a red. It means we're going to remain with a 2. We're going to remain with 2 which are red. Let me write them in a different color. We're going to remain with 2 which are red, right? Since 2 which are red, we're going to remain with 2 which are red. Since we've picked 1, so we're going to have 7, right? So even in this case, for what is going to remain for the blue ones? Let me put blue here. For the blue ones, what is going to be the outcome? Okay, so we still have 5 blue balls. We have not picked any blue ball over the 7 which have remained. Okay, then in an instance now we've picked by mistake. We've picked, since we want to, because it's random, it's chance. Okay, in the first instance, let's say we've not managed to pick a red ball. Now we are picking, we've picked a blue ball. Okay, how many blue balls do we have? We have 5 blue balls. Let's say we've picked one of them, so that would be 4 over 7. We've picked a blue, so I'm going to put blue there. Since we didn't pick a red ball, let me put red here. We didn't pick a red ball, so the red balls are going to remain intact. How many are they? They are 3. Okay, over 7. Basically this. Now what does this tell us? Every time, like we said, the highest number that you can have for any probability event happening is 1. The lowest that you are going to have is a 0. So if we're going to get this happening and this happening, these are the chances. If we add them, if I say 3 over 8 plus 5 over 8, what am I going to have? Since we have the same common denominator, I'm just going to say 8. Then I add what is on top. 3 plus 5, that gives me an 8. So I have 8 over 8, which gives me a 1. That's why we're saying every time you're not getting a 1, then there's something that is wrong. So what do we mean? If I also get this chance that we have, which is 2 over 7 and 5 over 7, I'm also going to get a 1. So you get your 2 over 7 plus 5 over 7. Okay, now 2 plus 5 on top, that is a 7. Since we have a common denominator, we're just picking 7. 7 divided by 7, that gives you a 1. So you're able to see any chance that you have, you always have a probability of 1. Probability of 1. Okay, basically that. Now at the end of this diagram, you can put, what this means is that if you are going in this direction, you've only picked red. Okay, basically that. Then you can also go in that direction, a red, then you've picked a blue. Okay, then if you are going this direction, you've picked a blue and a blue. Then if you go in this direction, you've picked a blue, then you've picked a red. Okay, so that's what it means. So basically at the end of these diagrams, you can be putting RR, and you can find that by just multiplying this and that, because that is for red and the red. Then there's RB meaning there's a red and a blue. Okay, and you can find that you're just multiplying these two. Okay, then there's a B and a B. There's a B and a B, so just put B here. Then there's a B and an R as the last chance, so you can have a B and an R. So you can be asked on either of these ones, what is the chance that you're going to get a blue and a blue? What is the chance that you're going to get a blue and a red? Any of the chances. However, like you said, depends on how they're going to ask you. If they say both, you know what it means, you're multiplying. Okay, there you're multiplying. So basically that. Now let's solve more questions on tree diagrams to just familiarize ourselves. So we are told that a bag contains 2 red and 3 yellow marbles. 2 marbles are drawn one after the other with replacement. They've told us with replacement. Okay, so how are we going to draw? Let's say we're trying to find the probability that both are red. Let's say they've asked us to find that if both are red, so let's do the tree diagram. So let's say this is a tree diagram. Okay, so let's say we have a red here and you have a yellow there. Let's say here you have a red, yellow, a red, oh, yellow, red, yellow, red. Makes sense when you put it like that. Then what do we now do? This bag contains 2 red and 3 marbles. So basically, how many marbles do we have in this bag? There are 5. Okay, so for the red ones, what is the probability? It that is 2 over all of them, which are 5. For the yellow ones, how many do we have? We've got 3, so 3 over 5. Now you are picking, 2 marbles are drawn one after another, after the other, with replacement. So you've picked, you've replaced, you've picked, you've replaced. So is the number changing in the bag? No. If I've picked, let me say I've picked a red, how many reds are going to remain in that bag? So I've picked that red and I've also replaced it back in the bag. How many reds am I going to have? I'm still going to have 2 reds in that bag. Over, the number is going to be the same because I'm still replacing it. How many is going to remain for the Y? The Y is going to be the same still because I've just picked a red, okay, and I've replaced it back. Then let's say, for example, I've picked a yellow, which is this. If I've picked a yellow and again I've replaced it, okay, how many yellows are there? There are 3. I haven't, from those 3, I haven't removed anything, I've still replaced, so it will be 3 over 5. When you come to the last one, okay, the reds are going to be the same because I haven't in case in this scenario I've just picked a yellow. This one you've picked a red, okay. Therefore then you're just now going to write, this is red, red, this is red, yellow, this is yellow, yellow, this is yellow, red. Then from here you're going to be asked whatever questions they want. If they're asking us to find the probability that both are red, both, what did we say? You're literally multiplying. So you're going to say the probability of us having a red and another red. That means you're multiplying this and that, because that's where we have the reds, okay. So that would be 2 over 5 multiplied by 2 over 5. Then you solve. 2 multiplied by 2 on top, that is a 4. 5 multiplied by 5, that is a 25. So that would be your probability. So that's how you solve this one. Okay, we have another question here. A box has 3 blue and 2 green discs. 2 discs are drawn without replacement. So always note, without replacement. Okay, let's say, before we solve any question, let's know what is a tree diagram, because our interest here is to first know about the tree diagram before we can now be asked questions. So basically, probability is one of the nice topics because it's not that complicated. Okay, we have 3 blue, okay, plus 3 green, plus 2 green actually. So what would be our final answer for these discs in terms of the total in that box? We've been asked in a box, so they are going to 3 plus 2, that is a 5. So in this box we have 5 discs, okay. So therefore, if I'm going to put blue here, this to represent blue, then the other happening to represent green, okay. Again, I can put blue here. Let's say we've picked a blue for this first instance. Then let's say for the second instance we've picked a green, like that. Basically that. Let's say we only have 2. That was just a single event. If it's a compound event, it will be going like that, going like that. It will be a very big diagram, of which maybe we can also solve the question that is in that line. But now solving this one, what do we have in the box? The chance for a blue. The chance of us having a blue, or the chance that we have in the box overall, we have 3 blue, so 3 over 5. For greens, we've got 2 greens over 5. Then let's say we've randomly selected, and for this time we've picked a blue ball, or a blue discs. Actually, these are discs. So we've picked a blue discs. So we have 3 discs in this box, and we've picked 1. So it means how many are we going to remain? We're going to remain with 2. Since we've picked 1 and we're not replacing it, so the box now is going to have 4 instead of 5. Why? Because we're not replacing it. We're putting it back wherever, maybe we're putting it somewhere. Okay, we're not replacing it. So always know their language. If they say without replacement, you're not replacing it. Okay, so that. Then since we've picked a blue, what is going to how many greens are going to remain? There's still 2 over, in this case to be 2 over 4. Okay, now let's say for the second, for another chance, you've picked a green. Greens, how many greens do we have? We have 2 greens here. Now if you've picked a green, that would be, you're going to remain with 1, so 1 over 4. Okay, however, how many blues are going to remain? The blues, you haven't picked a blue, but you've picked a green. The blues are 3, so it will be 3 over 4. Basically that. And every time, like we said, these should not be these all. Every time when you add them, they should give you a 1. Okay, same if I get this one and this one, they should give me a 1. That is a chance of you, those are the probability chances that you're going to have such, you know, happenings. So basically that is very, very important. Let's solve another question. Let's say 2 coins are tossed. What is the probability of having at least 1 head? 2 coins are tossed. What is the probability of having at least 1 head? At least. So we've been asked at least 1 head. Okay, okay, I'm not going to first use a tree diagram, but let's just again explain it the way we understand it. Let's say this is the first toss. Let's say this is the second toss. So for the first toss, we're trying to find the probability of having at least 1 head. Only 1. Now, since it's a coin, it only has 2 outcomes, right? You can only have a tail and a head. Now, for the first toss, what is the probability that we are going to have a head? The probability that we're going to have a head is half, right? It is 1 over 2. Okay, because it's 50-50. Okay, it's 50. Then what is the probability for the first toss that I'm going to have a tail? It's also 50-50. So it's going to be half. When I come to the second toss, what is the probability that I'm going to have a head? It is still 50-50. This is for the second coin. Okay, I've tossed this one. The probability that I'm going to have a head is this. Or there are 2 chances. I can also have a tail, which is that. Then I've come to the second coin. Let me toss the second coin. What is the probability that I'm going to have a head? It is still the same, 1 over 2. It's still half. For the second coin again, what is the probability that I'm going to have a tail? It is still 50-50. It's still half. Half just means there's a 50% chance, okay, that each of these events can happen. Now, we're asked the probability of at least 1 head. Okay, at least. So what are the outcomes? Okay, what are the outcomes? Now, to just before I just go direct to just put that, let me draw a grid before I just say it like that. Let's say this is the first coin, this is the first, this is the second coin. The outcomes for a first coin, there's a head and a tail. The outcomes for the second coin, there's also a head and a tail. Okay, so basically what outcomes am I going to have? Okay, so I can either have a head and another head. From the first coin I have a head, from the second coin I have a head. The other outcome that I can have, from the first coin I can have a head, from the second coin I can have a tail. Another outcome coming down, I can have a tail for the first coin, I can have a head for the second coin. Another scenario that I can have a tail for the first coin, then I can have a tail for the second coin. So basically these are the possible outcomes that I'm going to have overall. There are 4 of them. So now if there are 4 of these ones, which ones are the favorable ones? We are told you want at least having at least one head. Okay, so the probability that we're going to have at least one head is, now how many favorable outcomes do we have and what are the total outcomes? The total outcomes, we found that there's 1, 2, 3 and 4. These are all the outcomes that we can have, which is 4 outcomes. But in terms of the head, in terms of the head, at least that you have a head, in the first instance it gives you a head and the head, it qualifies. This one also gives you a head, or that gives you a tail, but at least there's a head there, so you count it as well. This one gives you a head, at least there's a head, there's also a tail there, but at least there's a head, so you're also going to count that. But are you going to count the last one, this one? You're not going to count this one because this one only has tails. So since you can't, so we're not going to count this one. So we're just going to count the first 3. Okay, therefore the 3 possible outcomes which we're calling favorable outcomes, there are only 3. So this will be 3 over 4. So what will be our final answer? That will be our answer, 3 over 4. So basically this is how you are going to solve this one. Then there's another question. A bag has 2 red and 6 black balls. 2 are drawn with replacement. What is the probability of having both black balls? Okay, so with replacement, we've been told with replacement, so we are literally replacing, so we're not getting anything from this bag. What we get, we return. So in the first draw, if I'm going to, let's say this is our box. Okay, so let's say this is the red and this is black. Okay, this is the first when they are in the black, in the bag. Then you pick, let's say after picking you have a red, you've picked a red. Okay, then Secondly, you've now picked a black over a red. Okay, so this is what we have. Now, how are we now going to solve this? 2 are red, 6 are black. So 2 red plus 6 black. Overall, how many balls do we have in this bag? There are 8. So since we have 8, the probability of red balls in that bag, how many are there? So there's 2 over 8. 2 over 8 is the same as 2 into 2, that is 1. 2 into 8, that is a 4. So I'm going to write 1 over 4. The simplified version. Then when I come to the black balls, we have 6. Okay, so we have 6 over 8. Then this can also be simplified. I'm going to divide 2 into 6, that is a 3. 2 into 8, that is a 4. So here we have 3 over 4. If we add these ones, they'll give us a 1. Okay, basically that. If they don't give you a 1, meaning you've made a mistake somewhere. Then now that we have this, let's say after picking, we've picked a red ball. Now we've picked a red ball, but mind you, we are replacing that red ball. Okay, so it means the red balls are still going to be intact. We know that there are 2. You've picked 1. Okay, but in this case, if we're going to use this number, you've picked 1 and you're replacing it, so the number is just going to be the same. Okay, so that would be 1 over 4. For the blue ones, it's going to be 3 over 4. Then for the next one, let's say you've picked a blue in this time around. So since you've picked a blue and again you're replacing it, so that will still be 3 over 4. Okay, and 1 over 4 for the red. Nothing is going to change for the red. So basically that. Now what will be the probability of having both black balls? Since it's both, you are multiplying. Okay, so both, we're going to say both black. We're saying both black, right? So let me just write this at the end. So this is red, this is red, black, this is black, this is black, red. The probability that you're going to have black is here. So it is 3 over 4 multiplied by 3 over 4. So if I say 3 over 4 multiplied by 3 over 4, what do we have? So basically every time I have the common denominator. Anyway, let's just multiply. So 3 multiplied by 3 on top, that will give me a 9. 4 multiplied by 4, that will give me a 16. That will be my final answer. Okay, so basically that. However, these numbers that we've reduced, you can still maintain the way they were without reducing them, but they'll still give you the same answer. What I mean, the one that we had to, the probability was 2 over 8. You are going to also have 2 over 8 here if you're not doing anything to them. Then here we had 6 over 8. Still here you're going to also have 6 over 8. This will be 2 over 8. This will be 6 over 8. Still, it will be still the same answer. You're going to be multiplying 6 over 8. 6 over 8 multiplied by 6 over 8 on the other side, and you're going to get your final answer. So basically that. Okay, let's solve another one. Okay, so this will be the last question in this probability marathon. just trying to answer this one. So a bag has 3 yellow balls, 2 red balls, and 3 white marbles. 2 marbles are picked at random, one after the other. Each color is noted and not replaced. Mind you, they've said not replaced. So these are the terms we are looking for. Then we're told to draw a tree diagram to illustrate the information above. B, we're told to use our diagram in A to find the probability of picking both red balls, both yellow balls, both marble is of the same color, at least 1 red marble. Okay, so what do we now do? So let's draw the tree diagram. Okay, so first, what is the total? What is the total of these events? So we've got 3 yellow, 2 red, and 3 white. So we just have to add those ones to find the total of these marbles in the bag. So we have a 2 plus a 3 plus another 3. 2 plus 3, that is a 5. A 5 plus a 3, that is an 8. So we have 8 total outcomes. So since this is what we have, what do we now do? Okay, we now draw. So if we draw, everything now will be simple for us. Okay, where can I just draw this? Okay, let me just use this same diagram so that we don't leave out anything. So let's say this okay, if this, okay, so this is going to have 3, let's say this and another one here. Okay, this one is going to be a bit let me use the diagram here. Let's say since this has 3, so it just has to look big. Okay, so again, this is going to give you 3 like that. You're going to have another one that gives you 3. You're going to have the last one that also gives you 3. Okay, basically this. Now what colors do we have? We have red, we have a red, yellow, and white. Okay, red, yellow, and the white. So even the other side, I'm going to put a red. This is okay, that is red. We've picked a red. Let's say we've picked a red, then the others are going to be maintained. A yellow is going to be maintained, a white is going to be maintained. Then let's say for the second one, I've picked a yellow, so I'm going to put yellow here. The red is going to remain, the white is going to remain. It's going to remain the same. Then let's say for the third one, I've picked a white, so I'm going to put a white here. Then the other 2 are going to be remained. Red is going to remain, yellow is going to remain, yellow is going to remain, yellow, like that. Okay, basically this. Now what do we have? So basically for red, 2 marbles are picked at random. So I told 2 marbles are picked at random, one after the other. Each color is noted and not replaced. So we're first trying to draw the tree diagram. So basically, for us to draw the tree diagram, what do? We just have to now, for the red ones, what is there? There are 2 red marbles, so that would be 2 over 8. That would be the probability. What about the yellow one? This is red. Yellow, what will be our probability? Yellow, we're told there are 3, so that would be 3. It will be 3 over 8. This is yellow. What about the last one, which are white? White, what are we going to have? How many white do we have? We have 3 as well, so it will be 3 over 8. These are what we have. So let me just write them now here. So I've got 3 over, for the red ones I've got 2 over 8. For the yellow is 3 over 8. For the white it's the same, it's also 3 over 8. Okay, now I'm picking without replacing. Okay, so I'm picking without replacing. So now every time I'm picking without replacing, everything changes. Okay, so in this case, let's say from those I've picked a red ball. If I've picked a red ball from these 8, so it means I'm going to remain with 1, right? This will be 1 over 7. Okay, then the other ones are going to maintain. So here I'm going to have 3 over 7. The white one, they're going to have 3 over 7. Then let's say for the second instance, now I've picked a yellow. Okay, if I've picked a yellow, how many yellows do we have? We've got 3. So I'm going to have 2 over 7. Then everything is going to maintain. How many red balls do we have? We've got 2, so that will be 2 over 7. How many white do we have? We have 3. We have 3 over, it will be 3 over 7. Then let's say now I've picked a white. So if I've picked a white, what do I now have? A white, in this case, there are 3 whites. So if there are 3 whites, I'm going to have 3. Or if I've picked a white, therefore I'm going to have 2 over 7. Then the other ones are going to maintain. Reds, we have 2 over 7. Whites, we are going to have 3 over 7. And every time you add these ones, like we've said, this should always give you a 1. Okay, for example, if I get 1 over 7 plus 3 over 7 plus 3 over 7. Okay, so because we've got the common denominator, which is 7, I'm going to add what is on top. 1 plus 3 plus 3, that is a 7. 7 divided by 7, that is a 1. Every time you have this, it means you're doing the right thing. Okay, so basically this is what we have. Now what are our questions? So let me just put them. So this is red, then there's red, yellow, then there's red, white. So this is red, white, then there's yellow, then there's yellow, red, then there's yellow, white, there's yellow, okay, there's yellow, then there's a white. Okay, then there's white, then there's white, red, then there's white, yellow. Okay, white, yellow. So like we've said, yellow, white and white, yellow are 2 different events. So you can't say red, white and white, red, yellow and yellow, red are the same. These are 2 different things. That's why you just have to write them the way they are. That's the principle of listing when it comes to probability. Now we are asked, what are we asked? We are asked to find the probability that both balls are red. Okay, both balls are red, so I just going red, right? Red. So we've got 2 and 1 over 7. 2 over 8 multiplied by 1 over 7. What do we have? This is equals to 2 multiplied by 1 on top, that is a 2. 8 multiplied by 7, that is a 8 multiplied by 7. what is it? Is it 56? 56, yes. Then 2 into 2 is 1. 2 into 56, 2 into 5, that is a 2, remainder 1. 2 into 16, that is an 8. So basically it's 1 over 27. This is red, okay? Both of them are red. That's the first one. Then the other one asked both are yellow marbles. So if both are yellow marbles, we want yellow, okay? Want yellow is here, okay? Yellow for the first one, it is 3 over 8. Yellow for the second one, it is 2 over 7. So I'm multiplying 2 over, so I'm multiplying 3 over 8 multiplied by 2 over 7. Then we solve. 3 multiplied by 2 on top, that is a 6. 8 by 7, that is 56. Okay, then we divide. We look for two numbers. 2 into 6, that is a 3. 2 into 56, we've said it is a 28. So if 3 can't go into 28, therefore that would be our final answer. As simple as that. Then we are told to find if both marble is of the same color. Okay, what is the probability that both marble is of the same color? So from this, which marbles have the same colors, or which results have the same colors? So we've got this as the same color, which is red. We've got yellow. We've got white. Those are the only combinations that have the same color. So we'll have to find the probability for that. So I'm also going to write it down. So the probability, okay, let me just write it on top. Probability that you have the same color. Same color here, we mean the probability that you're going to have red. So you can either have red, you cannot have all of them at the same time. So you can either have red or white or yellow. That's what it means, okay? So if that is what it means, because what it means is you've done your trial for the first one, you've gotten red, then another trial, let's say another trial, try again, get a red. So that is what it means, okay? So you can only have that. You can't have a red, then you have a blue, then you have a red. No, we just want a red and the red direct, a white and the white direct, a yellow and the red yellow direct, following each other, because you're just picking two marbles, or let's say balls from this bag. Now that you have this, since we said O, what did we say O goes with? O goes with either, right? And either you're adding, okay? If it was and or both, that would have been multiplication, okay? So basically that. So because of that, we're going to multiply the red, we add them to the white, we add them to the yellow, okay? Red we found, yellow we found, we just haven't found for white, okay? Basically, but we can just put everything together. Red, it is 2 over 28, 2 over 8, and the other red is 1 over 7. So I'm going to write it on the other side. So I've got 2 over 8 for the first red multiplied by 1 over 7. This is red, or we're going to put a plus here. We come to the other side, yellow, I've got 3 over 8. The other yellow is 2 over 7. Okay, 2 over 7. So I'm going to have, for yellow I've got 3 over 8 multiplied by 2 over 7 plus. Okay, for the last one, white, The first white is 3 over 8, the other one is 2 over 7. Okay, so I'm going to multiply that as well. So I have 3 over 8 multiplied by 2 over 7. Okay, we're saying this is yellow, yellow, this is white, white. Okay, basically this. Then all we just have to do is to solve. So that will be the final answer after we do that. So yeah, red gave us an answer which we solve, but you can still solve. 2 multiplied by 2, 2 multiplied by 1 on top, that is a 2 over 8 multiplied by 5 by 7, that is a 56. Plus, I come to the other side, I also multiply these ones. What am I going to have? 3 multiplied by 2, that is a 6 over 56. Plus, again, since these ones are the same, this one also going to give me 6 over 56. Now that I've got this, what do I now do? If I want, I can add everything or simplify them further. Okay, so 2 over 56 we said is 1 over 28, we solved that one, plus 6 over 56 we said that is 3 over 56, plus 6 over 56 is still the same as 3 over 56 as well. So basically this is what we have, since we have, it's not over 28 guys. Okay, 28 plus 3 over 28. Okay, that is what we have. Since we have this, we have the common denominator. Every time you're adding and the common denominator throughout, just get that denominator and add what you have on top. So we've got 1 plus 3, that is a 4 plus a 3, that gives us a 7. Okay, so basically the probability is going to be 7 over 28 that you're going to have those ones with the same color. Okay, basically this one. Now let's solve the last question. The last question, we're told at least one red marble. At least one red marble. Okay, so if it's at least one red marble, so there are a lot of combinations. So which combinations have at least a red? Okay, so how many are they? So since we're already highlighted, let me just use a blue color. So we have a red. So we've got this one, it has a red Y, this has a red, this also has a red, Y red also, and W red. So how many blues do we have here? 1, 2, 3, 4, 5. There are 5 of them. So basically you have to find those ones and multiply them, because that's where there is a red. At least we have a red in such a scenario. So let's write them. So let's use an so if I'm going to say you are going to have red white, red yellow, or you can have yellow red, or red white, or you can have white red, or you can have red red. Then everything that you have now, you just have to multiply. Red white, red, and or red yellow, it is red is 2 over 8, white yellow is 3 over 7. So I'm going to write that 2 over 8 multiplied by 3 over 7, plus I come to yellow, red, yellow, then red. So red there is 2 over 7 as well. Yellow is 3 over 8. So I'm going to write here 3 over 8 for yellow multiplied by the red, which is 2 over 7 on the other side. Or is the same as plus. So I'm going to put a plus. I come to the other side, red, it is red, white. Red, we said it is 2 over 8 multiplied by what about the white? So red, then the white. So let's say I have a red, which is 2 over 8, then I have a white, which is here, that is 3 over 7. So I'm going to write that 3 over 7 here, 3 over 7, plus I'm going to put white and red. White and red, what is white here? Okay, let's go back. White is 3 over 8 and red it is 2 over 7. Okay, so I'm going to also write that. So we're saying for white and the red, for white we're saying it is 3 over 8 multiplied by, for red we're saying it's 2 over 7. Then we have at last, let me put a plus here. For the last one we have a red we say 2 over 8. Okay, then the other red it is 1 over 7 here. Okay, so I'm multiplying this by 1 over 7. Okay, then what you have, you just have to now solve. That is your job. Okay, basically that. Then 2 multiplied by 3, that is a 6. That would be a 6 over a 28. 6 over a 56. Okay, plus when I come to the other side, I'm going to have 6 again over 56, plus I'm going to have a 6 over 56, plus I'm going to have a 6 over 56, plus I'm going to have a 2 over 56. Basically this. Then you just have to now simplify. You can divide throughout. You know that 6 over 56, I'm going to 2 into 6, that is a 3 over 2 into 56, we said it's a 28. So everything that has 6 over 56 will be giving me 3 over, to be giving me 3 over 20 over 28 plus 3 over 28 plus 3 over 28 plus, then this other one is going to be different. 2 into 2 is 1, 2 into 56 it is a 28 as well. Then every time you have the some common denominator, just get the common denominator and add whatever you have on top. Okay, so 3 plus 3, that is a 6, plus another 6, that is, okay, 3 plus 3 plus 3 plus 3, that is like 6 plus 6, which is like a 12. A 12 plus this one, that will give me a 13. So I have a 13. Since there's no number that can go into both, this will be our final answer. So this is how we solve probability problems. Thank you and see you in other sessions. Please don't forget to subscribe to our channel.